Welcome to a very quick, hopefully, video on tangents and normals. So, look, we've been learning differentiation, we've been learning calculus. And the idea of calculus is this. Let's say you have a function, y is equal to f of x. Now this could be something like, for example, y is equal to x squared plus 5x. Okay? You have y is equal to x squared plus 5x. Now, y, it's the y coordinate. And the idea is, to find the y coordinate, you sub in a value of x. So for example, what is the y coordinate? What is the y coordinate when x is 1? Well, what is y when x equals 1? Well, you sub x equal 1 in. Y is equal to 1 squared plus 5, 1, which is equal to 1 squared is 1 plus 5, and that's equal to 6. Okay, so this equation here, it's all about the y coordinate. If I give you an x coordinate, if I tell you, I'm just going to make up a graph, let's say that is -5, and that's a 0, and let's say that is the curve. Okay, and I'm pretty sure it actually is as well. Regardless, let's say that's the curve. Now on this curve, if I tell you what is the y coordinate when x equal to 1, well, when x is 1, what is the y coordinate? You will say, well, the y coordinate is 6. When this is 1, then the y coordinate is 6. And we know the coordinates of that point, 1, 6. So this basic equation, I like to call it the basic equation, it gives you the y coordinate if you sub in a certain value of x. Okay, now moving on. Now, what happens when you differentiate this? When you differentiate this, you will get y dash. And y dash is the gradient function. Y dash is the gradient function, or y prime, whatever you want to call it. It's the gradient function. Y dash tells you the gradient of that same curve. It tells you the gradient of the same curve at a certain point. So for example, if we sub in x equal to again, so if I said to you, what is the gradient? What is the gradient when x equal to 1? Well, you will say, okay, to find the gradient, I need y dash. You need y dash. And then you're just going to sub x equal to 1 in. And so you sub x equals to 1 in, so f prime of 1 is equal to 2, 1 plus 5. 2 times 1 is 2, plus 5 is 7. And then you can say to me, the gradient of that curve, the gradient of that curve is 7. That's rising by 7 for every 1 unit that you go across. Okay? Alright, so hopefully you've understood so far. Now I'm going to introduce tangents and normals. Okay? So you've understood why the basic function, y is equal to whatever. You differentiate it to get the gradient function. The gradient function just tells you the gradient of that same curve, because we differentiated that. And so the y prime of that will give you the gradient of the curve at a certain value of x. Now I'm going to introduce tangents and normals. So just bear with me when I rub all this off. In fact, there's probably a quicker way to do this. Yeah, that seems to be working. Alright, okay. Now, if I said to you, note that we're still using the same curve, okay? We're still using the same curve. Just for the sake of, let's just say it's -5 and 0, okay? We're using the same curve. And actually, you know what, I'd write a bit neater. Just so I can illustrate certain concepts. Okay, so we were talking about x equals to 1, okay? If I said to you, what is the tangent? What is the gradient of the tangent at x equals to 1. Well, the thing is, that's exactly the same as what we've just done. It's exactly the same. Because at x equals to 1, x equals to 1, 1, we're still at 6, we're still at 1 comma 6, right? The tangent will have the same gradient as the curve. In fact, the gradient of the curve is the gradient of the tangent by definition. Okay, that's the actual definition of it. And so we will still do y dash is equal to 2x plus 5, and then you find 1, and then you'll end up finding 7. So you'll say the gradient of the tangent at x equals to 1 is 7. Okay? And what's the normal? The normal, if someone says to you, what is the gradient of the normal? Well, the normal is simply same point as before, and it's just at a 90-degree angle. So 90-degree angle to the tangent. So it's perpendicular, and two lines which are perpendicular have negative reciprocal gradients. The gradients are negative reciprocals of each other. So if the gradient of the tangent is 7, then gradient m of the normal will equal to negative 1 over 7. So gradient of the normal is negative 1 over 7. That's it. Okay, moving on. Now we'll just talk about the equation of the tangent and equation of the normal. So we know the gradient. So we know that m of tangent. In fact, you know what? I'll just do it from scratch. So if the question says, find the equation of the tangent. Find the equation of the tangent at x equals to 1. Find the equation of the tangent of the curve that at x equals to 1. Well, you would do the following. You'd say, okay, to find the equation of a tangent. Well, first of all, what is the tangent? Tangent is a line. The tangent is a line, as I've illustrated before. Tangent, this is the tangent, and that's a line. So the equation of a line can be written in two different ways. You can write it y equals to mx plus b, or you can write y minus y1. In fact, I mean, there's several ways to write it, but these are two of the ways. This is the one that you're probably the most familiar with, but another way you could write the equation of a straight line, y minus y1 is equal to mx minus x1. And we're actually going to be using this second type of the second equation. And the reason we're going to be using the second equation is you need only two things. To use the first equation, to use that equation, you would need to know m, which is the gradient, which we can find out. Past 5 minutes, that's what I've been doing. I've been finding the equation of the tangent and so on. So m is not a problem. But b, the y-intercept, I'm sure I can find it, but it's not convenient. However, the second form of the equation, this one, is particularly useful in this situation, because what do you need to write an equation of a line in this form? Well, you need the gradient of the tangent, which we can find easily, and you need to know a point, x1 comma y1, right? And we know the point. We know it's 1, 6. Remember, we found 1, 6, the original function, the original equation, so to speak, is y equals to x squared plus 5x. So if it says x equals to 1, find the equation of tangent at x equals to 1, the first thing we'll do is we'll find the y coordinate. We find y is equal to 1 squared plus 5 times 1, and then you'll say, oh, it's 6. And then so you know the point. You know that we're trying to find the tangent at the point 1 comma 6, and the gradient, which we also know because you differentiate and you sub x equal to 1 in, and the gradient is going to be 7, if I remember correctly. And so we can write the equation of the tangent by just writing y minus y1, which is 6, is equal to m, gradient, which was 7, x minus x1, which is 1. And I'm done. That's it. The equation of a tangent is that. An equation of the normal is going to be similarly fairly straightforward. We know the gradient is going to be negative 1 over 7, negative reciprocal, right? So I know it's going to be negative 1 over 7. That's the gradient. And the point is, the normal is still going through the same point, 1 comma 6. So it's still going through 1 comma 6. And so it's just going to be y minus 6 is equal to negative 1 over 7 x minus 1. I use this point and I use that gradient to sub in to y minus y1 equals mx minus x1. Okay, and look, for some reason, I'm not really sure why, but students really struggle with this. They learn it, in chapter 8D. That's when you first get exposed to it. For example, question 15, find the equation of the tangent and the normal, to that curve at the point, blah, blah, blah. And students learn it in 8D, and by the time they get to 8E, they've forgotten it. Even though there's a question exactly the same thing. Hence, find the tangent normal to the curve at those 2 points, right? And they've forgotten it. And they learn it again, and then by the time they get to 8F, and then 8G, they forget it again. And then they get to 8H, and they've forgotten it again. And it's exactly the same question. Exactly the same question. They get to 8I, they'll forget it again. And it's exactly the same type of question. So this is an attempt. I'm going to try and show you that it's no different. So let's do a question from 8D. So this is the curve. Y is equal to 9 minus x squared. And we have to find the equation of the tangent. Look, I won't do the normal because normal is basically the same. One of the later questions I'll do the normal. But this one I'm just going to do the equation of the tangent. At the point 1, 8. Okay, so x is equal to 1. X equals to 1. Y equals to 8. I mean, if this is a random curve, and I'm sure that's not the actual curve. But you know what? I'll stop being lazy. I'll draw the actual curve. So 9 minus x squared, that's what? 3 minus x, 3 plus x. And so it'll be something like this. Something like that. And at the point 1, it is at 8. Sorry, 8. Let's find the equation of the tangent. Alright. So, first thing, I know I've got the point already. To find the equation of the tangent, remember, I'm going to be subbing into y minus y1 is equal to m x minus x1. What do I need? I've already got the point. I've got 1, 8. I've got x1, y1. I just did the gradient. How do I find the gradient? Find the gradient function. Y dash is equal to negative 2x. I'm going to sub in x equals to 1 because I want the gradient at x equals to 1. So the gradient is going to be 2, 1, which is 2. The gradient is 2. So the equation of the tangent, is simply y minus y1, which happens to be 8 here, because our point is 1, 8, is equal to, gradient is 2, x minus, and I'm done, that's it. And if I had to find the equation of the normal, well, the gradient, which is 2 here, the gradient of the normal would be negative reciprocal, negative half. And I'd literally just write negative 1 over 2, and that's it. I'm done. That's the equation of the normal now. Move on to the second type of question. Sorry for the coughing, I don't know, it's very dry. And exactly, differentiate f of x equal to 12x. So we have f of x is equal to 12x to the minus 1. Differentiate this, and you get negative 12x to the negative 2. And that's just negative 12 over x squared. Okay, and hence find f dash 2 and f dash 6. We have to find those two. And find tangent normal to the curve, that and that. Look, I'm just going to do it at this point only. I'm just trying to demonstrate how do you find the equation of a tangent. It's no different, regardless of what the point is, right? The procedure is the same. So I'm just going to find these. I'm just going to find that. Hence find f prime of 2. Well, f prime of 2 simply means I just sub in 2 now, right? Negative 12 over 2 squared is going to be 4. Negative 12 over 4 is negative 3. So I've got my gradient of, so I've got y minus y1 is equal to negative 3 x minus x1. And hey, look, I've got the point as well, 2, 6. Makes it easy. 6, 2, done. I've got the point, I've got the gradient, I'm done with the equation of a tangent. That's all there was to it. And the only thing that's really changing is the way we differentiate. We get to 8g and find the values of y and do y dx at the point P where x equals to 1. Well, when x is 1, what is y? Because I need to know the whole coordinate, right? Y is equal to 5, and I wanted an x equal to 1. I'm just going to sub 1 in. So 5 times 1 is just 5. Minus 4, all to the 4. That's 5 minus 4 is 1. 1 to the 4 is 1. So my x1, y1 is now going to 1, comma 1. Now I need the gradient. Find the equation of, let's do the normal. Change things up a bit, right? Find the equation of the normal. I need to know the gradient of the tangent, and then I'll take the negative reciprocal. So what's the gradient of the tangent? Well, y dash is equal to 4, 5x minus 4, all to the power of 3, multiplied by the derivative of the inside, which is 5. And that's 4 times 5 is 20, 5x minus 4. So that's the chain rule, right? The way I'm differentiating is changing, but the way we find the equation of the tangent is basically the same. You need the point, x1, y1, and you need the gradient. Well, at x equals to 1, what is the gradient? I'm going to sub f of 1 in. Or I'm just going to sub 1 here, right? I'm just going to sub in 1 here. So I just write a bit neatly. Come on. 25, and I sub 1 in. 5 times 1 is just 5, minus 4, all cubed, and that's going to equal to 20. 5 minus 1, 5 minus 4 is 1, 1 cubed is 1, 20 times 1 is 20. So my gradient is 20. Equation of the normal is going to be negative 1 over 20. And so I can write down the equation of my normal. Y minus y1, which is 1, is equal to negative 1 over 20, x minus 1. And I'm done. I've got the equation of the normal. If I wanted the equation of the tangent, I would write 20 here. I would just write 20 here instead of negative 1 over 20. And that's it. And then we can move on to 8h. Find the equation of the tangent. Let's do the tangent this time. Show the derivative of that is that. Okay, don't worry about that. We're just going to differentiate it. I'm sure we'll get the right answer. So find the tangent at the point 1, comma 1. Notice I've already got the point. I just need the gradient now. That's all I need. So y dash is equal to u dash. Okay, so I differentiate the first, leave the second, plus differentiate the second, leave the first. Okay, u dash, let's differentiate the first. 3, 2x minus 1 squared times the derivative of the inside, which is 2, and then we're going to multiply by leave the second alone. And then I do a plus. Now I'm going to differentiate the second one. 4x minus 2 times the derivative of the inside, which is 1, multiplied by the first one, which is 2x minus 1, all cubed. And I can see they factorize it, so let's factorize. Is equal to numbers first, nothing common. 2x minus 1, I can see there's at least 2x minus 1. There's at least squared, so there's going to be left over. I'm just going to keep that in mind. Let's see what... Oh, actually, we could pull out the 2 from both of them. So let's pull out a 2. So that's gone. That's gone as well. And can I factorize that x minus 2 all to the 4? X minus 2. Did I make a mistake over here? When I differentiated the second one, I should have been cubed there. Okay, that's odd. I thought I wrote it. Anyway, 2x minus 1 all cubed. Now I'm going to pull out the x minus 2, and I can pull out the third power of it. So x minus 2 cubed. That's going to disappear. Remember, I factorized out the 4, so that's going to be a 4. It's a quick reminder for myself. And I pulled out 3 powers, so that's going to be 1. And then what's left over? 3. X minus 2 plus, there's a 2 left over, and there is 2x minus 1. I pulled out 2, so there's 1 left over. 2x minus 1. And hopefully I should get the right answer. 2x minus 1 all squared. So I'm just comparing it over there to see I've got the right thing. I seem to have done the right thing. And then let's just expand this. 3 times x, 3x minus 6 plus 4x minus 2. 3x plus 4 is 7x. Minus 6 minus 2 is minus 8. And I can see I've got the exact same thing as them. 2x minus 1 all squared. X minus 2 cubed. And I have successfully differentiated it. Okay. Now, remember, I do need to find the gradient at the point x equals to 1. That's what I'm trying to find. So let's sub x equal to 1 in. If I sub x equal to 1 in, what do I get? I get 2. 2 times 1 is 2. 2 minus 1 is 1. 1 squared is just 1. 1 minus 2 is negative 1. Negative 1 cubed is negative 1. Okay, 7 times 1 is 7. 7 minus 8 is negative 1. And so my gradient is going to be negative 1, makes a positive, it's just going to be 2. And so my gradient is 2, so the equation of the tangent is going to be y minus, remember it's at this point, so y1 is 1. Y minus 1 is equal to gradient is 2, x minus 1. And I'm done. And so, as you can see, hopefully I've given you plenty of examples. The procedure is no different, really. Look, I could give you a question we haven't done yet for the class of 2021, which is why I originally made this video for, who I originally made this video for. We haven't done the question rule yet, so I'm not going to confuse you with that. But just suffice it to say, it's just a different way of differentiating, a new method of differentiating when two functions are being divided. But the equation of a tangent is going to remain the same. You need the point, you need the gradient. To find the gradient, you differentiate, you sub the x value in, and you get the gradient. Anyway, best of luck. I hope this helps. I found myself explaining this again and again and again and again. And I hope future students can find this useful as well. Best of luck.